This is Year 11, Chemical Reactions and Energy Changes, Lesson 3, Breaking and Making Bonds, pages 18 to 24. I know it's got a similar title to Lesson 2, but we're looking at actual values of making and breaking bonds today. Now in your booklet on page 18, it's quite easy to show the size of energy transfers involved in chemical reactions by looking at the amount of energy transferred to an individual bond. An individual bond is broken or made. This is called bond energy. Now the size and value of breaking a bond is exactly the same size or value as making a bond. So that's something you need to remember, and you need to write it in page 18. So let's look at some calculations. We're going to look at question 1. When methane burns in oxygen, two products are made. Carbon dioxide and water are the products. Now you should be able to write me a word equation by rereading those two sentences. And then you should be able to write me a balanced chemical or symbol equation, it says in your book, by again looking at your word equation and transferring them into symbols. The only one you'll struggle with is methane, and methane is capital C, capital H, with a little 4 at the bottom by the H. CH4. Now if you've done that, what you should end up with is methane add oxygen, arrow carbon dioxide and water, and then I've given you an unbalanced equation and a balanced equation. It's very important that we balance our symbol equations. So CH4 is methane, O2 is oxygen. We know O2 is oxygen because it's two atoms covalently bonded together. We've got CO2 and H2O, and you're all familiar with those. Now that is unbalanced. So what we need to make sure when we balance an equation is we have the same number of atoms on the left hand side to the right hand side. And you can see once it's balanced, I've got one carbon on the left, one carbon on the right. So one carbon there, one carbon there. I've got 4 hydrogens, and I've got 4 hydrogens there because it's 2 times 2. I've got 4 oxygens, 2 oxygens, and that 2 goes all the way through, 4 oxygens. Remember, when you're balancing, you can only put numbers in front of formulas. So then we need to look at what bonds are being broken and what bonds are being made. And in your book, you've got this. You can see that the bonds in methane, you've got 1 carbon with 4 hydrogens attached to it. So you've got 4 bonds there. You've got 4 CH bonds. And then you've got 2 molecules of oxygen. Now the reason you've got 2 molecules of oxygen is if we go back to this balanced equation, I've got 2 lots of oxygen molecules, right? So this is why it's important that you balance your equation. And then you're making 1 molecule of carbon dioxide and 2 molecules of water. If you look back at your balanced equation, you'll see why I've drawn 1 carbon dioxide and 2 water molecules. Now the energy needed to break bonds is endothermic. You have to put energy in. The energy released making the new bonds is exothermic. It releases energy, so it's the heat energy is given out. Now you'll be given these in the exam. Bond energies, you'll be given to them in the question. And the value, remember, for making or breaking is exactly the same. The bond energy will be given to you in kilojoules per mole or kilojoules. You just use the units that are given to you in the table. Per mole just means per molecule. It is a standard measurement, a mole. It's a certain number of particles, but just for these equations, we just need to know that it's the amount of energy per molecule. It says calculate the overall energy change for the reaction. Is it exothermic or endothermic? Explain how the result tells you this. The following will show you how to work it out. Breaking bonds are those. Making bonds are those. Now I've drawn them in for you. The easiest thing in the exam, or whenever you're doing this, is to break your page in half. Breaking on one side, making on the other. And it'll say the overall energy change, we work that out, and then we can work out whether it's an endothermic reaction or an exothermic reaction. So breaking bonds, if you look back, we've got to break 4 CH bonds. So if you look back at our molecule, we've got to break 4 CH bonds. We've also got to break 2 lots of O double bond O, because we've got 2 molecules of oxygen. And then the making, we are making 2 lots of C double bond O and 4 lots of OHs, because I've got 2 water molecules there. So I've got 4 lots of OHs. You should be able to see that. Now the values are given to you in the question. They're on page 21 in your booklet. So 4 lots of CH bonds are breaking. 4 times 413, which equals 1,652. 2 lots of O double bond O, which is 2 times 498, which is 996. And you add those together and you get 2648. Then making bonds, we're making 2 lots of C double bond O's and 4 lots of OHs. Again, we add them together and this side makes 3,466. Now, the overall energy change, what we're looking for there, we need to look at which side has the biggest number. And because the making bonds has the biggest number, it's going to be overall exothermic. And the overall energy change is the difference between the 3466 and the 2648. So you take them away. But because this side, the making bonds, is bigger than the breaking bonds, we put a minus sign there to show that it's exothermic. Heat is given out. Okay? And in the question on page 21, it gave you the bond energies in kilojoules per mole. So that's what you write your answer as. It is an exothermic reaction because the amount of energy released making bonds is greater than the energy taken in breaking the bonds. So in other words, this is a bigger number than that. Remember, breaking bonds, making bonds. Okay. Your next question. Hydrogen burns in chlorine to make hydrogen chloride. Is the reaction endothermic or exothermic? Again, you're given the bond energies, kilojoules per mole. And we're given the symbol equation. Write a word equation for that and make sure it's balanced first. It's very important that you balance it because the bond energies are per mole. And so that is per molecule, if you like, of the reactants and the products. So there's your word equation. And the symbol equation isn't balanced. So you should have put a 2 in front of the HCl. So you're breaking 1 lot of HH, 1 lot of ClCl, and you're making 2 lots of HCls. So have a look at that, make sure you understand where those breaking and making have come from. And then what you need to do is you need to fill in the bonds being broken and made and the values of each, just as we've done before. And you can see I've set out the equation a bit different. Breaking, breaking, making, making. You get your values on that page there. So you're breaking 1 HH and 1 ClCl. So those are your values, and the total is 679. And making bonds, you're making 2 lots of HCl's, 2 times 442, 884. Again, this number is bigger. So you can see already that it's going to be an exothermic reaction. By how much is it an exothermic reaction? Well, you take them away, and you always put a minus sign in front to show that it's exothermic, because the bigger number is on the making side. An exothermic reaction because the amount of energy released in making bonds is greater than the energy taken in breaking the bonds.